Hi, I'm Phil, and today I'm going to look at my last motor project in the course, Robots for Seniors. So we'll open up the mind map on projects, and the last one is the LIT project. And we'll just open that up to see what my desktop looks like. And this is the project on my desktop. It's a lift driven by a motor, which is on top. Now, this is one arrangement. I'll be looking at a couple of arrangements for the motor. In this case here, I'm using a Fischertechnik XM motor. And on the bottom, I've got a H-Drive unit connected to a motion base. And the motion base is just below an Atom computer. So perhaps we can just open that up and have a look at all those components. So the top one, here's my motor. This is the overall arrangement on the side. The lift goes to 3 different levels. And on the lift, I've also got a time of flight sensor, which can sense how far away the lift is from the ground level. Here's my motor, and there's my time of flight sensor in the lift. And my computer controls, I've got a dual button on the top left, and on the bottom left, we've got our Atom computer sitting on the motion base, and the H-bridge is on the right. This is what it looks like on our Atom LCD screen. So we're updating the screen with the height and the voltage that's coming in, and it shows us the direction that we're going. Okay, so we might have a look at the objective for this project. We'll just open up on that. We're going to control a lift, up, down, and stop. And we'll use push buttons and show the status on the Atom LCD. We're going to measure the height of the lift. We're going to request the lift using the dual buttons. See, red to go up and blue to go down. And we're going to use the H-Bridge Drive Unit to move the lift. So our design, the minimum will be level 1, the middle will be level 2, and the top one, the maximum level, will be level 3. So let's have a look at the hardware. From M5Stack, we're using a AtomS3R computer, and the cost of that is $17.50 US. And for the base, I'm using an Atom base, and the cost of that, if you use the more recent ones, they're all the same price. So you can go across and have a look at that. And for the unit, I'm going to use a H-bridge and a dual button. So we go to the top, we've got our dual button, and we're also using a time of flight, which we'll be using to measure how high the lift is away. And they'll all be connected by Grove cables. We actually need 3 Grove cables for this project. And there's the lift, and the lift looks like this. So there's a motor on top, and it's moving the lift cage up and down. The overall cost of that from eBay was just over $10 for the whole project, and you assemble that as a project. So this is what it looks like. The motor, well, there's a motor on the lift, so I'll be using that, but I'm also going to use a Fischertechnik motor, which is a Fischertech XM motor, one of their more powerful motors. Software-wise, I'm going to, before we go to software, let's have a look at the connections. Okay, so here's our project. We've got our Atom computer sitting on top of the motion base, and that's all in the middle here. On the right, we've got a H-bridge connected to the Fischertech XM motor, and we also have going into port A the time of flight. Now, the socket is colored red. That means it's an I to C connection. We're using port B for our dual push button, and that's a GPIO connection. And our motor is connected to M1 socket on the Atom motion. So we can actually control two different motors in this project. And the pins, you can see the pins here, we're using for port B, GPIO 7 and 8. And this is how the dual button is connected. It's connected to port 7 and 8. Okay, so let's move across to our software now. I'm going to use UI Flow 2, and I'm painting the screen so you can see the triangles represent if the lift is going up or down, or if it's stopped. And I'm going to update the status of the lift with H for height, and I'll show that on label 1. V will be for voltage, and that's the voltage that's coming in from the H-Bridge drive. Okay, so the resources that we use for that, we need a motion base, and for units, we have the H-Bridge drive. We're not going to use the APIs for the push button or the dual button. We'll use pin interrupts instead. Okay, so we'll might have a look at the software. Now, for the software, we have to make sure that we've enabled the pin button and the pins. And our code looks like this. So we'll bring that across. This is our total code, and we might go across and have a look at that now. So for our software, we go across to the M5Stack website, and we select software and UI Flow version 2. And when that comes up, we're going to select the AtomS3R computer. It's already on the screen, but here we are. There's all the different computers available from M5Stack. So we've got the right computer, and we're going to paint the screen here. And to do that, you just select the component or the object and the various labels that you want to put on. Okay, so we do that. And we're also going to make sure in our software that we have the right components available to us. And for the hardware, we want to have the pin and the button pins available to us. We don't really need the others, but they're there anyway. Base, we're going to select a motion base, and that's been assigned to the I to C port. So all of that is gradually being filled in as we select the components. The units, we're going to have a time of flight, and that's the first one. And our time of flight, when we go down further, we've got our time of, there it is, time of flight, and we get the commands that we can use with that unit. We've also going to use a dual button, DUAL, and that's been assigned to G1 and G2. We don't want to do that. We want to do a custom, and it's going to be on 7 and 8. So we'll confirm that one. And we've got our base, we've got the time of flight, we've got the 2 units, and we're ready to go. Now, I've set up all the software, and here it is here. This is the whole program for our lift program. And on the top left, we're setting up. So we might zoom in and have a look at that. Okay, so that's set up. Before we do that, we might have a look at the screen. I've painted the screen now, And this is what it looks like. And I'll be referring to the labels 1, 5, 3, and 6 throughout the program. So when we look at the setup, what we're doing is initializing the hardware, the motion base, the time of flight, the dual button, and the H-bridge. They're all being updated for us. And the motion base, the addresses here, and all the commands which are orange in our code all belong to the motion base. The dual button is the pink one here. So the dual button goes over here. And we're going to update our circle and 2 triangles, which you can see here. I'm putting the colors in on those. Then I set up the parameters for each of the levels. So when I go to the base level, it's 4.5 centimeters. The middle one is 8, and the top level is 13 centimeters. When I want to go down, I set the parameters for up and down and the speed for my lift. So when I go to my loop forever, I'm updating what's available on my dual buttons, and I'm getting the current in amps and showing that on label 3. So that's on the bottom. We've got C for current, and we're updating current. And we're also updating voltage and sending that to label 5. Then we display the height, and when we see if we can find that one, we'll go to display height, which is right on the bottom. We just get our time of flight and set that to label 1. Then we check the height to see if we're at the right level. Checking height is over here, and we can see that we can stop the lift depending on where we are. Our dual buttons are used to request an up or a down depending on which button we've pressed. And if we go to lift up, we then turn the motor on and we go forward. Or if we want the lift to go down, we reverse the motor, and we're updating our screen as we go along. If we press button A, we stop the lift. And that's the software for our lift control program on the Atom computer. So how did all that go? Well, the results were that I was able to achieve the results. I controlled the lift up and down and could stop it. I could also measure the height of the lift, and I used the push buttons for going up or going down. And the H-Bridge Drive Unit was able to move the lift. But I could also move the lift with the motor that came with the lift kit. And I don't know if there are any issues. It only works with H-Bridge Unit 1.1, and if you use 1.1 or 1.2, you can also measure the current in the H-Bridge Drive Unit. And stay tuned, and we'll have a look at a desktop demonstration. In this project, we have a simple lift controlled by an electric motor. So the handheld control has a lift up and a lift down. So if we want to make the lift go up, we just press the lift and we stop it. And if we want the lift to go down, we press the green button. And I've added 2 weights to try and offset the balance on the lift, because I've added a time of flight, which is a laser rangefinder, and it's used in the next project to find where the lift is in height. And that's our lift project. And before we go, we'll just have a look at the electric motor and the gear mechanism. Here we have the Atom lift version 2. And the lift module is a wooden structure, and the lift is here, and it's got a time of flight height sensor, and there's an electric motor with a simple worm gear box on top. And I've added some extra weights to improve the balance of the lift. And the electric motor's been driven by a motion base, and that's on the bottom layer. On the top layer, we have a AtomS3R computer. And there's a H drive. At the moment, the H drive is not connected, but we could drive an alternative lift. The time of flight sensor goes into port A here, and we have push buttons. So if we want to start the lift, we just press the red button. And at the moment, it's already on the upper position. If we want to lower it, we just press the blue button. And to go up again, we press the red button. And that's the Atom lift.